But eventually you're going to wear that ceramic material off and it'll touch the steel plate on the back, and that's why your brakes will grind. Hey guys, welcome back. Steve here with 6 Star Automotive. Sorry I missed you guys last week. I was in training in Seattle at ATE, which is the Automotive Training Expo. I want to make sure that I'm the best owner that I can possibly be. I'm never going to stop going. I love training. I love learning things. And one thing I learned from the training, one of the keynote speakers during one of the meals, his last thing was never stop learning. And that's, if I were to give you one piece of advice for whatever you do, never stop learning. So I'm going to start a new series today about brake systems. I thought about doing all this in one video, but I don't think I'm going to be able to get it all done in one video. So I'm going to go over the basic principles on how this system works, and we'll go over the nomenclature of what each of these parts are called, and hopefully you learn a lot from this series. But before we get started, remember, like, subscribe, and join me as we talk about brakes. So one thing that I found from the last couple of weeks of writing service myself, as I've been trying to hire another service advisor, is a lot of customers don't actually know what the brake components are and what they mean. I can use this forum to just allow you to kind of, on your own, learn, and that way you'll understand what we're talking about when we talk about calipers and brake pads and rotors and what all this stuff means and why it does what it does and why we recommend replacing them rather than turning them. So let's start from the very beginning. The part that you actually interact with. The brake pedal is connected to a lever. The lever goes to a booster, and the booster allows the effort that you push onto the brake pedal to be amplified into the master cylinder, which is this piece right here. The master cylinder is where all the magic really ends up happening. The master cylinder is where we convert mechanical energy into hydraulic energy using Pascal's principle or Pascal's law. Pascal's law states that pressure applied to a confined incompressible fluid is transmitted equally in all directions throughout the fluid. Basically stating that when you press on the piston that's inside this master cylinder, the fluid that's incompressible in this system transfers that force directly to the opposite end and pushes on the other pistons equally. That principle, along with the booster, allows you to exert a massive amount of force on your brakes, which we'll get to in a second, in order to stop the car. From the master cylinder, the fluid goes to what's called a modulator valve. The modulator valve is usually integrated into the ABS pump assembly. So this is where the magic of anti-lock brakes kind of happens. So I think we'll go over ABS in a separate video. That has to do with the ABS. The hydraulic fluid goes through the lines and to the caliper. This is the caliper assembly. When you hear us talk about that, the caliper is in essence an hydraulic ram that exerts pressure on the brake pads, forcing them into the spinning rotor and stopping the car. So on this side, you can actually see that the caliper is bolted to the steering knuckle. It doesn't connect to the rotor at all. I'll do another video eventually about wheel bearings to kind of explain what is allowing all of this stuff to turn and still be connected to the car. We'll get there. But the rotor itself is this circular piece right here with these little fins in it. So the rotor is bolted directly to the hub, which is part of the bearing assembly. And that is what spins and is connected to the steering knuckle itself. And then the wheel with the tire is bolted to the hub over top of the rotor. So the rotor will go on first, the wheel will then bolt onto that. So as the wheel spins, the rotor spins at the same rate. So conversely, as the rotor is slowed down by the force of the caliper, the wheel then slows down as well. And technically, it's the friction between the tire and the road that actually slow you down, not the, but anyway, we'll get to that later. Like I said, there's a lot going on here. But when we speak of brakes, what we're talking about generally is the caliper and the rotor assembly. So this is a standard disc brake setup. In the back here you can see, and we'll go over this one in another video, but this is a drum brake setup. Not really common anymore, but still in a lot of cars. So we'll go over that later. So let's get a little bit deeper. So this is looking at the caliper that we just saw before with the hydraulic section removed. So now we can actually see what's going on inside. The pistons are still here, and then you have the brake pads. So the brake pads are housed inside of the brake carrier, which is bolted to the caliper. So the carrier is part of that caliper assembly. The pads sit in little grooves that are inside the carrier, so they can only move in and out sliding inside of these, which is why it's important that this upper portion and this lower portion stays free of rust and debris and corrosion. So what it's saying here is that with good pads, you're going to have even braking force being applied all the way across the pad onto the clamping of that rotor. So if we were to look at the rotor, we'd be looking at it like this. And if we were to turn it thusly, that pad sits and it pushes here. So it pushes on both sides and clamps on to this rotor like this. That transfers the kinetic energy of the vehicle into heat and dissipates it through these rotors. Let's see what can happen when they start wearing out. So as the brake pads contact the rotor, over time you're going to wear that material or that ceramic down and it's going to wear off. That ceramic material is bonded to a steel plate on the back that keeps it from coming off, basically. But eventually you're going to wear that ceramic material off and it'll touch the steel plate on the back, and that's why your brakes will grind. When you hit the brakes, you're actually scraping a metal plate against a metal rotor, and that's where you get that grinding sound. And this right here is actually a perfect scenario. Super even and perfect wear. This is 100% of the monetary value of these components used up. Unfortunately, this is not always the case. Very often, actually, what you end up seeing is this pad will wear unevenly in any one of the axes. I will show you an example. So this is an example of a brake pad that we use to show customers kind of how thick and thin that they can be and get when we talk about them in millimeters. So we talk about you should do your brakes at 2 millimeters. Well, what does that even mean? So most brakes that we're going to do on Subarus and Asian vehicles is going to start off about 8 millimeters, which is right about here, about this thick. As it wears down, it starts going down 6, 5, 4, 3 is getting into the, hey, it's time to start looking at replacing them. And then 2 millimeters is really as low as we want to go. And the reason for that is not that we want to replace it before they're grinding. I mean, of course we do, but this pad, as it pushes against this rotor, is not always going to push on it exactly flat. It can actually turn like this and get stuck inside of that carrier one way or the other. So you can have it wearing like this, right? Or like this, or any manner of those kind of combined. So by the time you get down to 2 millimeters, the likelihood that you have even wear across that brake pad is very, very, very low. So at that point, what we can see, because we can only see it like this, as the brake is sitting in the brake caliper, usually you'll have just a little kind of inspection area across the top of that caliper, and we can only ever see here. So if we see 2 millimeters up here, the likelihood that we have 2 millimeters down here is not 100%, right? So we want to make sure that we get these things out of there before you say, I'm going to go to Seattle or something, and then you leave at 2 millimeters, and then by the time you get there, or halfway there, the 2 millimeters that you had up here is actually only 0.5 millimeter down here, and then you're grinding by the time you're halfway there. We don't want that. You don't want that, I don't want that. So this is an example of those worn brake pads in a carrier pressing against a rotor. So as those brake pads wear down, eventually you'll end up having the metal to metal grinding, and then that's going to reduce your braking force and then increase your stopping distance. All right, so last thing I'm going to go over in this video is during a brake service, what do we do and why do we do it that way? So during a brake service, we're going to replace the brake pads. We're going to replace the brake pads every time. Obviously, that's kind of the things that's the wear item. Everybody's going to do brake pads, so we're going to do that. We replace rotors every time. Some people don't necessarily do that. If we lived in California, Arizona, maybe I wouldn't necessarily do it that way. But here, see these fins on the inside, they actually eventually get full of rust. And then that limits the rotor's ability to flow air, which then limits its ability to dissipate heat, and then you have issues with warranty. Turning rotors is something that is a relatively fine art. It is not something that is as simple as it seems. Getting rotors to be true and getting them to be even and smooth like they need to be it's actually rather labor intensive. And we found that the cost of rotors has come down to the point that it really doesn't make sense benefit-wise to turn rotors instead of replace them. Because now you have rotors that don't have any rust protection at all that we're going to put on there, especially, again, up here in North Idaho, it's the rust protection. Really is one of the main reasons, warranty and rust protection. So we're going to put on Akebono brake parts almost all the time. On anything, especially on anything Asian, we're going to end up using Akebono parts, which are fantastic. I mean, the best reliability that we've come across, least amount of noise and least amount of dust accumulation and production. They are just phenomenal. They seat in really well, they last really long, and they're just really good parts. Those are the reasons really that we're going to replace the rotors every time. I found that especially when rotors get warped over time, you cut them and then their propensity to warp again is higher than a newer, higher mass rotor. So I don't do it. I mean, there's too many times we've had comebacks and too many times that we've had issues with noises and just forget it. We just don't deal with it anymore. So if we do it, we're going to do brake pads and rotors every time. We don't do calipers every time though. So that's one thing that differentiates us from some other places. Anyway, I understand why they do it, and it's actually a relatively good reason, but the problem is replacing the calipers every time really doesn't make sense from a cost perspective to us. The calipers that are on your car are very high quality. We cannot put the calipers that came on your car back on your car for less than like $800 a piece, and that's the cost of a normal brake service. So it just doesn't make sense to stick calipers on every time if what we're going to end up doing is taking off those high quality factory calipers and putting on some. We'll go over that in another video. Anyway, the caliper will seize, cause the brakes to fail prematurely, and then we're back in there doing brakes faster than we should have. So a lot of places don't like dealing with that, so they just put calipers on every single time. I just don't agree. I want to get the maximum amount of life out of those calipers as possible because they are the highest quality that we can possibly put on there. So that's what we do. That's why we do it. So I hope you guys learned a lot from this video. Thank you so much for watching. I've got a lot more coming on this brake series. Stay tuned and come on by to experience the 6-star difference for yourself.